Good morning. We have with us today Derrick Du, who's the CEO of IoTank, and they have a company that is based on sensors. And so Derrick, I wondered if you could tell us about your background and how you got into this wonderful world of fog. And you can explain what we're talking about with fog.
Dennis, thanks for having me on here. I really appreciate the time that you're spending with us. So I actually I probably have a little bit of an odd background in getting into fog. I was working at Internet of Things startup prior to this, and we were developing, I was leading up their professional services team. I had a team of about 10, where we were developing our customers' IoT products for them in terms of hardware, firmware, how it interacts back with their backend system. And so with that type of knowledge, I thought that I could reuse that knowledge in other areas where there's a use for IoT. I grew up, born and raised in Minnesota, and in Minnesota, pretty much everyone goes fishing. It's a land of 10,000 lakes. So as everyone is going, since I go back pretty much every single year to be with my family, we also have an annual fishing trip. And the annual fishing trip usually is to one specific lake that we all really love. But over time, what we've seen is that that lake has gotten worse and worse. And there's less and less fish and more pollution in that lake. And so we were trying to figure out what was happening with these lakes here. And one of the problems was actually the septic tanks in that area were leaking into that lake. And so there was a lot of nutrient pollution that was building up. Even though this doesn't have to do with fog, we were actually we started IoTank by thinking about a solution for maintaining on-site wastewater treatment systems. And so we had actually presented our sensors, our first prototype sensors at WWETT, which is a pumper conference, on-site wastewater pumper conference in Indianapolis. And through a lot of the feedback that we got, which was predominantly positive, we saw that there was an opportunity in fog that we weren't actually originally thinking about.
And fog, by the way, is
fats, oils, grease, right? So in a centralized sewage system, fog generally is the main cause of sanitary sewage overflows. There's also other causes like roots that get into the piping or other things like that.
And wipes. Let's not forget wipes. That's a big pandemic thing.
Right. And so that's how we ended up entering the fog market instead of the septic market.
Mm-hmm.
In the end, we do want to be in the septic market and handle all on-site wastewater treatment systems, but fog just seems like a smaller, more niche market that we can enter and quickly prove out that the sensors work so that we can move forward back into the septic market as well.
And the main contributors of fats, oil, and grease in a wastewater treatment system would be restaurants, right?
Right. And for people who don't really know how these systems work, and it's the same for septic and grease, there's basically a restaurant here, and the pipes from the sewage pipes from the restaurant would go into a tank, and this tank would allow the water, grease, solids to separate out into 3 different layers. One layer at the top, which would be fats, oils, grease, a layer at the bottom, which would be all the solid waste, and then just the effluent layer is what we call it in the middle. These tanks generally are split into 2 different sections. So there's a wall here that doesn't allow, that allows you to separate out the fats, oils, and grease even more. And then there's an outlet pipe that goes back out to the centralized sewage system. And the idea behind this is so that you filter out any of the fats, oils, grease, and solids before it goes out to the centralized sewage system. And all the waste in here that's collected in here actually needs to get pumped out on a regular basis. Otherwise, you're letting out a lot of fats, oils, and grease that clog up on the back end here, clog up the centralized sewage system, which requires a lot of maintenance, requires a lot of work for the city to actually jet out all the piping that buildup has caused.
Yeah, so within these grease interceptors, there's it's basically like a gravity system, right?
Yeah, it's a gravity.
Just like a big open, or not maybe super big, but a big, say a cube, and within that, the separation is really kind of a gravity thing.
Right. Yeah. As I was saying, the fats, oils, and grease float to the top, and the solids go to the bottom, while the remaining water, the wastewater itself, just flows out of the tank, which is allows you to basically stop any sort of clogging on the output of that tank itself. So today, there's not really a good way to know when you need to pump out these tanks, and no one really wants to take the time to open up and inspect each of these tanks because it's a very time-consuming process. So the industry standard today is for septic tanks to be pumped out every 3 to 5 years, and for grease to be pumped out every single 1 to 3 months. But in reality, this could really be that a restaurant could be expelling a lot of fog, and that could cause the tank to be filled up within 2 weeks, or I think even in certain extreme cases, we've seen even up to 1 week. And so if this tank actually fills up in 2 weeks, it's causing a lot of excess fats, oils, and grease to actually flow out into the centralized sewage system. And then there might be one bend where it's all building up and then eventually causes a sanitary sewage overflow, which is a much bigger problem in terms of one, potentially transmitting diseases. Two, it's a lot more maintenance. And then there's also regulatory pieces here where the Clean Water Act also regulates how much untreated waste gets released back into the environment for each municipality. And so you actually have fines for the entire city that if you don't meet those regulations.
Yeah, and they're not trivial fines, actually. There's been some recent things in the Bay Area that about emergency releases into the Bay that, the fines were 6 figures. And and which the Bay Area Water Board, they have to levy. They were a little, they felt that the city involved, who I won't mention, were pretty good actors normally, and so this was, just sad, but it's a bad thing that gets pretty heavily punished. So
fines can be
important stuff.
The fines can be up to 7 to 8 figures, actually. So
yeah. This was a relatively small release, but it was a couple $100K.
Yeah,
and everybody's sorry about it, but the fact is it happened. So why don't you get into just with IoTank, the kind of the market when you're kind of doing some problem definition now, and to be interested in about the market and then how you'd address all this stuff.
So in terms of the problem definition, the market for us right now, we're predominantly focused on the grease side, where we're actually selling to restaurants first. So as we enter a new market, we're selling to the restaurants as a way to help prevent overflows in their restaurants, as well as just automate their maintenance processes. So with some of the restaurants that we've been selling to, they actually were already able to save hundreds of dollars per pumping, because we are able to collectively bargain with the pumpers. Let's say we have 100 restaurants on our platform. Now we can collectively bargain with restaurants on the pumping cycles and and the cost of the pumping. We can also do like route optimization. So actually, let me take a step back. The problem that we're really solving is the maintenance of on-site wastewater treatment systems. As I was saying, grease interceptors need to be pumped out every single 1 to 3 months, but it could vary depending on how the restaurant is using their interceptor. If they're being really diligent about dumping their grease into the right containers, their deep frying grease or other types of grease into the right containers that are not necessarily going straight into the grease interceptor, they're able to maintain that time period for a longer time period before they actually need a full pumping. And so how today is actually the regulations are generally set. The standard industry standard is that you need to pump out at 25% full. But again, there's not that many people who are checking on a regular basis. Even a well-funded municipality isn't checking every single grease interceptor because it's potentially thousands of grease interceptors in their city. And so there's no way for them to inspect every single grease interceptor, open them up, use a sludge judge, and actually get the levels on a regular basis. And so what we're creating is a way to enable that process. So we're creating the very first sensor that actually measures the sludge, scum, and effluent levels inside of a tank on a regular basis in real time, so that we're able to automate and coordinate maintenance across all of the on-site wastewater treatment systems. This will also make the entire ecosystem for how you maintain these systems significantly more efficient as we grow and as we have more and more installations in a specific area, right? So,
by the way, Derek, one item that came up just within restaurants right now, as there's reopening or expanding their operations, is that they're having a big problem attracting people to work
right.
in back of house in terms of the restaurants. So this is becoming a pretty big deal. There's a lot of articles about it and how people are getting cross-trained and dishwashers are getting trained to be line cooks, and bartenders are bussing tables and stuff. And I would think that the normal chaos of a kitchen is like getting expanded in this time period, and that can't have a good impact on the grease situation, because it would seem to me you'd have to be fairly disciplined about, you mentioned putting things in the proper places, and it would seem like everything would go into the interceptor or be more likely to happen.
Right.
So anyway, that's a bit of a restaurant review, backhouse review interjection.
Yeah, so you can even take this a little bit further, where you can imagine, especially now where a lot of new employees are coming into restaurants and they don't know the regular processes to maintain a grease interceptor. What we can do is we can understand how quickly you are increasing the amount of solids and grease in your interceptor, and we can compare that back with similar restaurants, right? Let's say we could compare, one Olive Garden with another Olive Garden, and see which one is being more efficient about maintaining their systems and maintaining the grease going forward. And then we can provide restaurants with more information about how they can actually do better work with maintaining their grease, as well as just letting them know what kind of financial savings they could have if they were maintaining their grease a little bit better, right?
Mm-hmm.
So like they would have to pump out less frequently if they actually maintained their grease interceptors, and that would allow them to save a significant amount of money over a long time period, right?
That's an interesting point you bring up with specifically with Olive Garden or kind of chains, groups of restaurants as well, that they can, kind of monitor this as a compliance issue. They can monitor it at their different locations. That's an interesting aspect. So as far as the sensors themselves, you mentioned they do a bunch of different things. So could you describe the technology, I guess, the sensor technology, and then, what you have?
So as I was saying earlier, is our sensor actually extends the entire height of the tank in terms of the water level. And so our sensor is measuring the amount of solids and the amount of grease that's being built up in each of these tanks. And then it's relaying that information back to our platform, which will be readily available for municipalities, for the restaurant owners to all understand more about what's happening in the state of each of the tanks. And so most municipalities have regulations based on the 25% full or pumping out at a 1 to 3 month interval, fixed time period. And
Mhm.
so, so we'll be able to actually tell you exactly what the level is in terms of how full you are. And we'll be the very first center that will actually be able to do this as well. So there's another piece to this that we're still researching and experimenting with, is being able to measure wastewater usage. So if we know your tank is, 1,000 gallons, let's say, we could also estimate how much wastewater you're using on a daily basis, and that becomes another piece of information that would be extremely relevant to how these tanks are being used going forward, and how much and estimating how much grease is exiting the tank. So in reality, even if you have a grease interceptor, there may be some amount of grease coming out of the tank at all times, even when you don't have even if your tank is not 25% full, right?
Mhm.
So we'll be able to, based on the wastewater usage, estimate how much grease milligrams per liter is actually coming out of the tank, and that can give you a lot more information about which areas of your centralized sewage system are most at risk, right? So we were able to prioritize, let's say, sewage cleanings. So if a municipality has a team of people that are going out on a regular basis cleaning out their centralized sewage system, and you're talking about a city in the Bay Area that had this problem, we would be able to, based on all of the different tanks in a specific location and overlaying the centralized sewage grid with where all of the grease interceptor tanks are, we'd be able to guess and estimate out where the most likelihood of having a clean out spot needs to be. So you can prioritize your cleanings exactly based on how long it's been since you last cleaned out that location, and what are the tanks around there, and what kind of residual grease is exiting all those tanks over time. So it's a great way for us to help municipalities in prioritizing the right locations to clean out in terms of the centralized sewage system, because unfortunately, centralized sewage systems are very overbearing. They're just gigantic systems, and you need a lot of expertise to learn that. And by having this, you're able to further discern exactly where you should go be cleaning out.
Mhm. Yeah, kind of see what's coming, or see ahead around the bend as far as trouble points. Um, in So with this approach, I wanted just even to get into just say the advantages of this approach, and different benefits. I mean, I'm not sure in this particular space. I mean, this seems like a really good application of sensor technology to kind of let's say an old world problem, and to give and with all the advantages of that information, both to the individual restaurant and their ownership, as well as their treatment facility,
Right.
as well. So it's has a lot of multiple uses. Um, and I'm not sure, what, there's a classic competitor question, pops up. I mean, how else is this being handled, and how is, and this approach seems pretty logical, but I don't know how you want to address that.
Yeah, so we're actually the first ones that are building a solution for this. There have been some other attempts at building a solution for this, and it actually is a difficult problem to solve, both at a technical and a physical installation process level. And so there have been a few other companies that have tried building ultrasonic sensors that will work within these tanks.
Mhm.
Unfortunately, because of how these tanks function, the fats aren't always extremely soluble. You might have globlets of fats moving around. So our sensors are actually measuring the densities of materials around it and letting you know what the density levels are. So it actually allows you to even see the variations along the tank. So you can imagine if there's a tank, it's not necessarily, okay, no, that's fine. If there's a tank, there's not necessarily a very straight line across the tank that's saying this is all the fog, right? It's actually, you know, the fog might be moving like this, but what we're measuring is around the sensor itself. We're actually measuring the density, so we can say that even if there's globlets over here, but you know there's water in between, we can actually tell you, oh, this is really only, you know, 25% dense, right? Rather than the full density, which would be the extreme top layer, right? So with this approach, we're able to give insights about tanks that, you know, that we've never been able to see before, and provide an understanding about, you know, what regulations are working, what regulations aren't working. You know, if we can, well, the main goal is to really prevent system failures or having anything exit the output baffle of the tanks themselves that would impact the, you know, the downstream components. So in conclusion, I think there's really not any competition in this market for us, and we're not just building a sensor, we're actually building an entire system, an entire platform that will help make the ecosystem maintenance of all of these things a lot better in terms of any sort of on-site wastewater treatment system. And not just that, we can, you know, the sensors are just enabling a lot more that a lot more possibilities than we can even think of as of right now. So one thing that we've learned about in the last year is there's still a lot of dumping of waste as the pumpers come out and pump out each of these on-site systems. They may not want to travel, you know, 100 miles to the local you know, wastewater treatment center, right? That would actually take the waste, and that would cost them a lot of money because they have to pay for gas. The operating costs associated with it is actually pretty expensive.
It's very interesting. I hope, I'm sure a lot of people didn't come into this thinking so much about the back of the house restaurant, you know, kind of fat, oil, and grease, but obviously it's there, and it's actually quite an interesting system that does have a big impact on, you know, our clean water. Very good talking to you. And
Thanks so much
so
for having me,
Derrick,
Dennis.
well, yes, so it's IoTank once more. We'll put up, we'll have some contact info on this as well, in case you're so intrigued that you want to learn more from Derrick and his company. Thanks again.
Thanks, Dennis.
Thanks for playing.
All right, we'll talk later.
Okay.